I would like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. Thanks again for joining us for today's TechNet webcast, 24 Hours of SQL Server 2008 Data Mining. Now it is my pleasure to introduce today's first presenter, Donald. Donald, you have the floor.
Okay, thank you very much. Welcome to this 24 Hours of SQL Server 2008 and to this data mining session in particular. I'm really looking forward to this session. I've been looking forward to telling people a lot about what we're doing in 2008, and it's also great for me to be presenting with Lynn Langett, who is a developer evangelist, who's got a great enthusiasm and passion for data mining. So I think we're going to give you some really useful information and hopefully show you some good demos, and I hope you get some great stuff from this. The idea of what we've been doing in 2008 is really quite interesting because a lot of people have used data mining in SQL Server 2005. So the things we're going to cover in 2008, we won't necessarily just start from scratch. But what we will talk about is, first of all, the data mining add-ins for Microsoft Office. This is a new feature which we introduced originally in SP2 of 2005, and we've really built them up even more in 2008. So for those of you who are familiar with this stuff, we think we'll see something new. We'll see some of the compelling new features that we've added to the add-ins. For those of you who haven't seen the add-ins before, step back, be amazed. There's some really, really cool stuff in here. Another thing we're going to look at is a bit more detailed and for the more advanced user, which is the idea of partitioning data into training and testing sets, and that's for a slightly more advanced user, but even the beginning user will find this quite useful information. We're going to cover interface improvements we've made to the mining model, how you actually work with the mining model directly. We're going to talk about a feature called cross-validation, which is a testing and validation feature, which again you'll find useful to evaluate your models. And we've also made some changes to our time series algorithm, which we've had a lot of requests for, and we're going to be talking about that. So there's really quite a lot here, a lot of information, hopefully a lot of new stuff for you as well. In terms of the experience that you'd have for this, yes, if you've got experience of SQL Server analysis services, that's going to be great. I think that'll help you to understand some of the concepts that we're talking about. And of course, if you've got any familiarity with the add-ins already, then you'll find a lot of what we're talking about here is second nature, and in fact, you'll just be desperate to get your hands on this stuff. But even if you don't have this and you don't feel you're at the level 300, I still think you'll find this useful because it'll be an eye-opener to a lot of the capabilities, and hopefully it'll motivate you to get up to that level 300 of understanding. I think you're going to have a lot of fun with this. So with that, I'd like to hand over to Lynn, who'll pick up from here, and she'll be talking about some of the new features.
Great. Thanks very much, Donald. Well, welcome to everyone who's joining us. We have a bunch of demos and information to share with you about what's new in data mining in SQL Server 2008. And as Donald said, we realize that some of you listening might be completely new to the world of data mining, and we hope that you'll continue to stick with us for this hour because whether you're experienced or whether you're new, the things that we have to show you we think will be interesting and compelling. So those things are what is new in terms of the data mining add-ins that are part of Office, specifically inside of Excel for 2008. So we'll be talking about some new capabilities inside of there. We'll also look at some data mining structural improvements. And then, as Donald said, we'll be looking at the new cross-validation capability that's built in to test the accuracy of the models that you make inside of the bids. And then we'll be looking at the changes to the time series algorithm. As we go along, if you have questions, please feel free to write them in the question queue, and we will address them either live or when one of us is talking, the other one will answer the questions because we do want to make sure and answer all the questions that you might have. And if you have questions about core features of data mining, feel free to ask them as well. Although this is an advanced level presentation, we really do want to answer any questions that you might have about data mining capabilities inside of SQL Server 2008. So with that, the first thing that we're going to take a look at is a new capability that becomes available when you install the add-ins for Office for SQL Server Data Mining 2008. And although you don't see it on the slide, what happens if you're not familiar inside of Excel is you get two additional ribbons. And Donald will be demonstrating this in just a couple minutes, but just so you kind of have a point of reference. The ribbons are the Table Analysis ribbon and the data mining ribbon. And inside of the table analysis ribbon in 2008, we have two new capabilities, and one of them is this prediction calculator. And what you can think of when you're trying to understand the capabilities of the prediction calculator is that this is a viewer of a particular algorithm result. And the algorithm is the Logistic Regression algorithm. Now that might sound like a lot to bite off if you're not familiar with data mining algorithms, but what we've really tried to do with this prediction calculator is we've tried to add some visualization to the results that help the results to be more useful for you. So in a nutshell, what this does is it allows you to figure out which attributes are particularly influencing a predicted state. And in the state that we're looking at here is, in this example, which is the AdventureWorks example, what is the result of people who are purchasing a bike. So if you take a look inside of this slide, you can see that there are 4 different sections. And the first section allows you to specify what the results of incorrect result are. So you can see, as an example, the false positive shows a penalty of 10. And you can understand the rest by just taking a look at it. That's scored using the algorithm, and then the results are applied to the second section here, where the profit is calculated by threshold. Now, what isn't obvious in this slide, and what Donald will show in his demonstration, is that you can adjust or tinker with the false positives and true positives and so on and so forth, the cost and the profits, so that you can see the rate at which you can have the appropriate result. You can also see in the bottom right, you've got a visualizer that shows you the cost of an incorrect prediction, and then the last part of this is the scores and the relative impact of the associated attributes. So again, this particular sample is built off of AdventureWorks, and it's showing you the attributes that are related to the customers who purchase bikes. So if you're new to this, you can understand that in this case, for example, single is a lot more impactful in terms of purchasing, in terms of marital status, and so on and so forth. It's pretty immediately obvious. So in a nutshell, the idea of this is to give you a more usable visualizer. And again, this is found inside of Excel in the table analysis tools. So that's one addition. Donald, is there anything else you want to say about this before I go to the next thing?
Well, one thing to point out is that the idea of false positive and false negative costs, we will cover a little bit of that in the demo in particular, but one of the things to think about there is that sometimes in some scenarios, you're not necessarily thinking of profit. This is intended to give an idea for financial scenarios, but you may have a case where you're just scoring some other kind of model where there's not necessarily a financial element. In which case, you should rather think of those scores as being a tendency score or some sort of score of the relative importance to you of actually winning this customer or getting a true result or a false result. We talk about it in terms of profit because that's the common scenario, but you can map this to other scenarios as well if you need to.
Well, I know I've done some production work with the law enforcement, and so that's an application that I think of right away in terms of offender rankings. Yeah,
sure. There's no profit in arresting them, but it's important.
yeah, exactly. So anyway, another new capability that we offer in the Excel 2008 add-ins is the shopping basket analysis. And what this does is, again, it gives you a new type of visualization for the association rules. So if we just drill into the results here, you can see that the association algorithm will create item sets from source data. And what that is just what items are sold together. Sort of the classic thing in data mining is they call it the beer and diapers, where you have maybe unexpected pairings of items that are sold together. And then going through this, you can see that we then have a visualizer showing the number of sales. It's pretty obvious, actually, just from looking at it, the value per sale and then the total value of the bundle, so that you can, from a marketing standpoint, figure out which items are going to produce the best result for you if you market them together. So this has an additional view, and that's called the recommendation view. And drilling into this, you have the selection of the items, and then you'll notice you have the recommendation, and this is generated by the algorithm itself. And then continuing to go through. You have the sales statistics, which, as you see on the screen, are the sales of the selected items, the linked sales, the percentage of links, and then the all-important financial results, which is the average value of the recommendations and then the overall value of the linked sales. This, I don't know, to me, I don't know if the audience agrees, is a little bit more intuitive to look at than maybe the first thing that I showed, the prediction calculator, because it's just really showing what sells with what and how you're going to impact your results. So these two capabilities are part of the table analysis tools, not the data mining ribbon, which I know I have found to be maybe a little bit unexpected for some of the customers. And when Donald gets into the demo, maybe he'll talk a little bit more about why these new items were placed on the table analysis tools ribbon rather than the data mining ribbon.
For sure, yeah.
Moving on to the next feature. This feature is available inside of the data mining ribbon rather than the table analysis ribbon, and this is a pretty straightforward feature to understand. This is just simply you push a button and you get the documentation of the model metadata. Probably the most important parts of this are the algorithm parameter configuration values. As you become a more advanced data mining user, you're going to find yourself tuning and tweaking the algorithms in order to get results that are more meaningful for your particular business scenarios. And as multiple people work with your built models, it will become more and more important for those people to understand how you have tweaked the parameters. And you can see in this example, we've got association roles, which is the market basket. It's the same algorithm as we just showed. And in the parameters in the bottom, again, they're pretty straightforward, talking about the maximum number of item sets, the maximum item set size, so associate three things together, the maximum support, so on and so forth. Now, when you are starting to work with the parameters and learning about the parameters, we do provide documentation inside the dialog boxes themselves, and sometimes that's adequate. Sometimes you will have to go to the books online to truly understand, but you will find that more and more you are working with this, and I do believe that this addition came out of customer requests. Okay, so I'm going to turn it over to Donald to show these features that have been added inside of the Excel table analysis tools and the data mining ribbon. So Donald, I guess you need to share your desktop for this.
Yeah, sure. Thanks so much. So I'm just going to go over to the share my desktop now. And what we have here is Excel 2007. And we have the data mining added, which you can see the data mining tab appearing here. And we also have the table analysis tools. There is a difference between them, and visually you can immediately see quite a clear difference. The data mining added has a lot of features, and the features are arranged in essentially in a kind of workflow from left to right, where you start with preparation, move through modeling into accuracy and validation, so how you use the model and how you manage the model. Table analysis tools are quite different. They're very simple.
Donald, sorry to interrupt. Do you mind just putting your volume up a little bit?
Yeah, sure.
Thank you.
Okay. How do you think that is?
Oh, I think that's a little too loud.
Oh, right. Okay. How about that?
Can you say that again?
Did that make any difference?
Yes.
Yeah? Okay. So we've now seen the data mining ribbon and the table analysis tools. And what we're going to do here is simply go through a couple of the features that Lynn mentioned. We're going to, first of all, look at the prediction calculator. But one thing I want to do just before we do that is just explain the data that we have available. The data here is arranged, and obviously in Excel it's a grid, but we've formatted the data as a table. And that's very important for the table analysis tools. They work only against data which has been formatted as a table in Excel. If your data isn't formatted as a table, then you can simply go to the Home tab and just click the Format as Table button, and it will format your selection as a table object. And then you can use the table analysis tools. So I've got a fair selection of sample data here. In fact, I think there's a really interesting one we could use for the prediction calculator. This is a questionnaire which has been collected at a car show, at an auto show. And the questionnaire is so basically, what do people think of the concept of the car? with 1 being the lowest score and 5 being the highest. What do they think of the design, its advanced features, its environmental features, its practicality, and so on. And then there's 2 particular questions that people are always interested in. Would you buy the car? With 1 being, really I'm not interested, and 5 being, yes, I'm very interested. And can a dealer contact you with no and yes, the options there. And then we have some basic information we collected about demographics. And the purpose of the prediction calculator is, well, let's turn this into something that I can actually use with new customers to see if they are customers that I might be interested in buying or customers that I should contact. So in order to build this analysis, I'm going to go to the Table Analysis Tools. I'm going to click on Prediction Calculator. And at this point, what I'd like to do is the target, the thing I want to predict, is going to be, would somebody buy a car? And the score, I'd like to predict those customers who are 5, who've got the very highest score, somebody who is really excited about buying this car. And I'm going to take the 2 options of Operational Calculator and Printer Ready Calculator. I also have the option, slightly more advanced option, of going in and choosing the columns that I want to use. So I can say, well, I want to ignore certain columns. You'll notice that we've unchecked Responder for you automatically. And the reason for that is we know it's unique for every customer. We know that the responder ID is unique for every customer, so we know that's not interesting for discovering patterns or discovering analysis. So we uncheck that for them. I'm going to uncheck would you buy, because that's what I'm already analyzing, although that doesn't make too much difference. I'm also going to uncheck can the dealer contact you, because I kind of realized that when we're in the auto show, people who want a dealer to contact them are also very likely to be customers who buy. And with new customers that I'm contacting over the phone or by mail or whatever, I won't have that information. So I'm going to leave that out of the analysis. I'm going to click OK, and at this point I'm going to click Run. And what we do here is we build the data mining model on the server. I happen to be building it on a local server. We return the results into Excel, and now we get the view that Lynn was showing you on the in the presentation. And this calculator report tells me all the various factors that make up the calculations that data mining has worked out for us. So, for example, I might be concerned with the false positive cost. Perhaps these customers that I'm targeting, I'm going to go out and I'm going to make them a really special offer. I'm going to give them a free test drive. And that probably involves me, there's an insurance cost to that. There's a cost of gas. There's a cost of just having a car out at the showroom. There's a cost of sending somebody with them on a test drive. So actually the false positive cost, if I offer somebody a test drive and I actually, they don't buy the car, they're not really that interested, it's actually going to be quite high. So I'm going to say the false positive cost is about $100. The false negative cost? Well, false negative cost is if this is somebody I should have contacted but I didn't. And we'll leave that out at the moment as a value. But of course, true positive profit, that's really interesting. Now watch what happens when I change true positive profit. I'm going to assume that I can make 1,000 profit out of a customer if they actually do buy the car. And watch this number here, the threshold value. It's currently 668. That's the score a customer has to achieve in order to be counted as a positive customer. If I change this value to 1,000, you'll see that value comes right down to 310. And why does the score come down? Because I can make so much profit out of this that I can afford to target a slightly wider range of customers. My algorithm, my prediction can be a bit looser if you want, because the potential profit is higher. Just to show you that in action again, if I changed it to 500, you would see, in this case, that should go back up. But in fact, 310 is probably the lowest there. Let's go down to something even lower and say I was only going to make 100 profit. And there you can see the threshold goes up a little. So in this case, 1,000 profit, threshold of 310. And the other graphs and charts on the screen simply help me to understand the profit that I can make from these customers if I have false negatives or false positives. So now, having built the calculator, let's use it. I'm going to go to the Prediction Calculator tab, and based on what we did in the report, I can now get a typical customer, and imagine if I'm phoning somebody up. I'm actually doing a conference call with somebody right now, and I'm asking them over the call, do you like the concept of the car? Do you like the advanced features? Do you like the environmental features? And as I take notes on what they're saying, this prediction will either be true or false if I think they're going to be a likely car buyer. and I'll know whether to offer them the test drive or whatever. So for example, let's say that at the moment I'm going to say, well, they quite like the concept of the car. They're going to give it a fairly neutral 3. But they do like the design of the car. They're pretty positive. They're going to have that at 4. The advanced features they think are quite interesting. We're going to give that as a 3. But the environmental features, well, they're very enthusiastic about the environmental features. They're going to give that a 5. Practicality, yeah, they quite like practical features. They quite like the old car overall. In fact, they're very positive about the car overall. I'm going to give that a 4. Their age, well, it turns out that while I'm chatting to them, they're about 40 to 49, and you can see the score changing as I change those values. And it turns out they're actually on a pretty high salary. At this point, I can see that this customer isn't somebody that I'm particularly interested in contacting, so I wouldn't do that. But let's say we were able to get some more information from them, and it turned out that, in fact, they really liked the advanced features. And not only did we like the advanced features, but the whole concept of the car was interesting to them. Now, the customer's flipped over and is a true customer, and this is somebody I'd want to contact. And so this is the way you use a prediction calculator. It's a kind of interactive tool for proactively scoring customers. One of the interesting things about the prediction calculator is that this particular tab that I'm using at this point, this particular sheet, it is entirely based on, if you like, a truth table and a lookup table that we build up, which is at the bottom of the screen here. And that truth table is all that is used to perform these calculations. It's just a lookup value. There's no, if you like, there's no data mining happening on this sheet. So I could actually copy this sheet and put it in an Excel spreadsheet and use it even without access to the data mining server. This table has been built using data mining, but I can now take it away and use it somewhere else. And in fact, we've taken that concept even further, because if you go to the printable calculator, I actually have it's something I can effectively print out on a laser printer and go out and check the boxes. And it's just like one of those quizzes in Cosmopolitan magazine, you know, the Am I Sexy quiz or something. Not that I know about those things. But you can go through and, you know, check your score and add them all up at the end. And when you get to the bottom of that, you can add up the person's score and see if they're going to be a 5. Are they a likely buyer? Or are they other than 5? Are they not a likely buyer? So the prediction calculator from that point of view is a great way of using data mining, first of all, to perform predictions. It gives you very valuable predictions. But it's also a way of getting data mining, feel like, into production in a practical way. This is a feature we introduced in SQL Server 2008 specifically to make data mining even more usable than we did then previously. So let's look at another thing, which was the association rules, or as we call it in the simplified form, the shopping basket analysis. This is really very straightforward. As Lynn was saying, it's very similar to the old kind of beer and diaper story that people used to look at. People who bought this also bought that. In this case, we're in a coffee shop, of course, because we're broadcasting from Seattle. And there's filters and mixed scones and mochas being bought at the same time. And similarly, there's Americanos and coffee beans and filters being bought. And so what I'd like to do is, running this coffee shop, I'd like to understand the kind of offers and things that I can make. I can do this very easily by choosing the Analyze tab, Shopping Basket Analysis, and then all I have to do is map my transaction ID to the basket identifier, my product name to the item, my price, which is an optional value, to the price column. And having done that, just click Run, and again we'll build the analysis and return the results. And as Lynn showed, the results come back in a couple of forms. One of the forms is just to tell you what the various bundles are. And in this case, ordered by the overall value of the bundle, I can see that filters and coffee beans were my most valuable bundle in terms of the total amount of money that I made from those sales. There were 43 of those sales, but they brought in $263. In this case, for oatmeal raisin cookies and non-fat lattes were 64 sales, but they didn't bring in so much money because they're lower-priced items. So based on that, I can go back to the Shopping Basket Recommendation tab and say, well, okay, based on those patterns that we found, what recommendations can I make? And the number one recommendation, the top recommendation by value, is that if somebody comes into the store and buys coffee beans, recommend filters to them. That will be successful about 81% of the time, but the total value that brings in is going to be about $171. Now, if you look at the very bottom of this table, you'll see that if somebody comes in and buys a bagel and you offer them an Americano, based on what we know historically, you're probably 100% likely to actually make that sale. but it doesn't bring in a lot of money. It only brings in about $19. So it's a kind of certain offer, but on the other hand, it's not actually bringing in as much cash. So,
but it does give you business value. It tells you should raise your prices.
And that's actually true. Yeah, it does actually. It didn't tell you exactly that. This is a guaranteed offer. And one of the nice things about this being in Excel, of course, is that you can do things like sort it by the percentage of linked sales or sort it by the average value of the recommendation. There are a lot of things you can do and which you know to do automatically just because you're in Excel that you can play with. So we've built a couple of models here, and we've got some interesting results. One of the things that we hear from the more experienced data miners is, okay, this looks really cool. It's very easy to use, but do I really trust the results? And by the way, what just happened there? So this is where the documentation feature comes in and why we've had a lot of requests for that. I can go into the data mining tab, and I have this option to document the model. So if I want to document the model that I've built, I click Document Model. It walks me through a little wizard where I can go and choose the models that are there. Most of these models that I build automatically, by the way, have fairly obscure names because the names were generated during the execution of the wizard. But here's a model called Unfiltered Model from the Income Group, which we'll see later on in one of the other demos. Let's just document that just now by clicking Next. I'm going to choose Finish. I'm just going to take complete information. Summary information is actually pretty basic, just tells you the model parameters and the model name. But I'm going to choose Finish here. And again, we're going to document the model based on information from the server. And you can see here that we give quite a lot of information. We give the high-level information, what the algorithm was that we used. It was decision trees. When the model was last processed back in February. The number of trees that were built, the number of nodes in the tree, the columns that we used, interesting splits in the model by region, age, and amount, and information about the input columns and the parameters. Now, if I was to show you this and you weren't an experienced data miner and you'd say, oh my goodness, what on earth is complexity penalty, or what does force regressor mean? These are actually hyperlinks, and if I click on complexity penalty, it will actually take you online to our online documentation on MSDN for this algorithm, and will take you to the technical documentation page where you can scroll down. You can find out how this algorithm works, what's interesting about it, and at the bottom will tell you what all the various algorithm parameters are that we could have used. And I'll see that complexity penalty tells me that it controls the growth of the decision tree. So it's kind of really useful documentation from that point of view of giving you some sort of sense that this is something that's useful, reliable, and trustworthy, and that you want to use. So with that, I hope that gives you a kind of quick overview of what the add-ins are like and why they're interesting and powerful. And Lynn, if you want to talk about the review questions, I think that would be fun to see if people have actually understood anything we've been telling them.
Okay, great. Well, as I bring up the review questions, just a couple things, and you can go ahead and vote, and we'll see how you do. To use the add-ins, because I did answer some questions in the queue privately while you were demonstrating, you do have to have a connectivity to an analysis server because even though you are working in Excel, of course you are running the algorithms via the analysis server. Now, as Donald said on the prediction calculator page where you're doing the adjustments, that's based off of the truth table, and that can be separated. But for both of those algorithms, you do have to have that active connection to the analysis server. So which algorithm does the prediction calculator use? Wow, good thing we're doing this webcast. It is actually logistic regression. So we've got one person out there that was paying good attention.
And now that you've said it, you could too.
Yeah.
Too late.
That's okay. So we're going to keep on going here. So all right. So let's keep going into some of the other new capabilities. We're going to move out of the world of Excel and into the world of data mining structure improvements. And it was really interesting because we actually had a question while Donald was presenting that talked about something that has been added in 2008. But before we talk about that, let's look at this first enhancement, which is available as part of the data mining wizard when you actually create your mining models. And this is just something that you're going to find very, very useful. We have now the ability to automatically create training and testing sets of data. And for those of you who have been doing data mining for a while, you're probably just going hooray, because you'll know that after you create your model, you are going to want to validate it using our validation tools. And to do that, you feed your test set into the validation tools. It's one way to do that. So what we've done is we've just really automated this process through the wizard, and we also have the ability to set this via the property sheets. So you can see there we can do a percentage or a number of cases, which translates into a number of source rows. This is particularly helpful if you're building a model that contains nested tables, because it's just simpler to do it this way. Another straightforward enhancement is, and came from customer requests, is mining model column aliasing. Just very simple, again, to understand, taking source data that maybe doesn't have friendly name, in this case it does, but and giving it a more friendly and usable name. And this screen is showing that you can do this through properties, or you can do it through DMX over in the aliasing name section over here on the right side. This next thing was the question that I was specifically asked while Donald was doing the last demo. And this is an enhancement that is really exciting because it allows you to build more compact data mining models. For those of you who might not be familiar, when you create a data mining model, actually sort of the meta container is called a data mining structure. And what that does is it allows you to define in bids from the data source and the data source view which table or tables are going to be used as source data for the data mining models that you're going to create. So what we've done in SQL Server 2008 is we've added this ability for you to produce filters on the particular models, so that rather than creating so many models or large models, you can now just define these filters. And this is just available via a right-click interface right inside of bids. So you can see it's very straightforward. You just define the column and then the operator and the value, and basically you're obviously defining a query. This is also shown over here in the property sheet, and you can have multiple conditions. You also might note on the bottom of this dialog box for the model filter, we have the ability to go in and manually edit the query as well. Another enhancement that we've added, and this is kind of for a similar reason to the filtering that I just showed, was the ability to drill through not only to source data that's included in the particular model that you've created, but as you see here on the slide, we now have the ability to drill through to any column from the entire structure. And the business reason for this is to allow you to create more compact models. Of course, more compact models can be easier to understand and usually will process more quickly. So what this is showing you is the results of drilling through back to the source columns defined in the data mining structure that maybe aren't part of the particular data mining model. And this is accomplished through a right-click inside of the viewers. The bottom is just showing you DMX to be able to access that. Now, there are a couple of algorithms that actually don't support a right-click drill through, Naive Bayes and time series. Naive Bayes doesn't support drill through at all. Time series only supports drill through inside of DMX queries, not in the BIDS user interface. And also a couple more there: neural network and logistic regression. So got to be complete. Okay, so I'm going to turn it back over to Donald to show you how these new features actually work.
Thanks very much, Lynn. There's quite a lot in here, and we're trying to kind of move through it fairly quickly. I actually have a question which I just want to address just now before I get on to this particular part of the demo. The question was, if somebody is a business analyst, what do they need to know about analysis services? Pardon me. What do they need to know about analysis services in order to use these add-ins? Apart from, do they need a DBA to install it? But the idea of this, the add-ins, is really the kind of self-service environment. If your IT department has set up an analysis server for you, they effectively only need to create one database, give your permissions to that one database, and then from your point of view, it's actually, once you've got the connection straight to that database, it's very straightforward. You don't need to know anything about analysis services. You just kind of click and go.
Well, I think the other thing I would add, just from my experience with this, is you want to start with the table analysis tools, because that's a good point of entry. And once you feel comfortable understanding the functionality of the table analysis tools, then you would want to move to the full data mining ribbon, because it's really very, very powerful. And what I have found for people who are new to data mining is they can become productive more quickly by starting with the table analysis tools ribbon rather than just going straight to the data mining ribbon. So it's a little tip.
Yeah, I think that's true. It's like training wheels for data miners.
Yeah.
Having said that you don't need to know anything about analysis services, I'm now going to show you some of the advanced features in the analysis services environment. And the reason for that, of course, is because as a level 300 session, we know that there are already users out there who are familiar with this environment and want to understand the changes in that too. So let me just quickly run through how we're going to create a clustering model. And as I create the clustering model, we'll talk about some of the new features that we have that we've implemented. One of the first things we're going to do to create the model is, first of all, start with a structure. And in this case, I'm going to use an existing relational warehouse. And I'm actually going to create a mining structure without any models. I always think this is kind of new feature that we've added in 2008. It's a small feature, but it makes some of the other ones actually more useful and more usable. What I'm going to do is just take some AdventureWorks data, and I'm going to use the this view, which is available in default AdventureWorks install, called DM Prep, which is just a little view that we've created for using the data mining. And you can see that I don't have predictable columns here. I just have a choice of using, choosing all the columns which are going to be in my structure, and choosing, say, a key column. So I'm going to use that key, this customer key as my key column. And that's really all I need to tell it in this case for the structure. I'm going to go through and now hold out that percentage of testing data, and let's say I want to hold back, in this case, 20% of my data for testing. I can also set the number of cases, a maximum number if I wanted, but at this point I'm going to hold 20% back for testing. I can click Next and just say, call this the demo structure, and finish, and this is creating a structure. There's no mining models at this point. If I go into mining models, there's nothing here. So I need to add a mining model, and what I'm going to do here is add a mining model based on the clustering algorithm. I'll just call it clusters, and choose the clustering algorithm, and click OK here. And because I'm working over the structure, everything by default is like an input here, but I can say that there's things like, for example, the order number. The order number is never going to be an input to my mining model, so I'm just going to ignore that. The line number item, I'm going to ignore that too. I don't really need to know that. And even the customer key, I don't as a key column. So here's some things that order number and line number that I just don't want to use for data mining. But something when I actually come to analyze these customer clusters, knowing the order number of the goods they order might be quite useful if I want to follow up with them. And this is where then we move to the mining model viewer. We're going to save the model, load the new diagram, just a second. This will just take a second to load that up. Oh, I need to process my mistake. Back to the models and process. Save the changes and process the model on the server. Run the processing. This only takes a very short period of time. It's actually one of the advantages of using mining structures, that the mining structure data is cached on the server, and therefore reprocessing becomes relatively quick. You don't need to go back to the source system in order to get all the data. If I was to process another model over this, it would be almost instantaneous having done that. So that's very quickly processed that model. I can now go to the viewer, view the clusters. It will only take a second to come up here. Let's refresh this. It's going to load the cluster diagram, and I'll see, I think it's going to find probably about 10 clusters within this data. Having found the cluster diagram, I have all the usual ways in which I can explore the cluster diagram, but one of the features I really wanted to show you is the fact that even though I didn't use order number and line item as part of my modeling, I can drill through, and I'm being very forgetful today because I actually forgot to enable drill through. So if you come across this, you do drill through, and it's not actually checked, that means that you didn't enable drill through when you created the model. I'm going to go in here and check the properties of the model, and I'm going to enable drill through for this model. Normally this is a checkbox in the
Everyone will understand that drill through is not enabled by default.
Absolutely, yeah. Although that may be a feature request for the future now.
You have to reprocess?
I'm going to just refresh this, yeah.
Yeah. So I have a question for you, actually, Donald. So this caching the data, is this a new feature?
It's not. It's always been part of the mining structure.
Okay, I just wasn't sure. So that's interesting. So subsequent processes should be really a lot faster because of the cache data.
Yes, you don't have to go back to the source data. Yeah. It's really useful if you're pulling in, lots and lots of data from a remote server, for example. Okay, back to the mining model viewer. Refresh the content. And at this point, I should be able to drill through. And I can choose to view the model columns, in which case I'll just see the columns which were used for creating the model. And as you can see, these are all the ones which I used for modeling. Or alternatively, I can drill through and choose to see the model and structure columns. And when I choose to see model and structure columns, let's take a second to fetch those rows.
And, of course, because Excel supports these viewers with the data mining add-ins, you get the same functionality inside of Excel.
You can get the same functionality in Excel as well.
Yeah.
And here I have the line item and the order number. So if I wanted to kind of contact any of these customers or follow up on any of these customers, I have additional information. It could be things like their phone number, just things that I wouldn't use for modeling, but I may use for additional information. So that was some of the improvements in terms of creating a mining structure. One of the other things that we should talk about briefly is, in fact, what we used for creating the filtering, because filtering is a very, very powerful feature within 2008, which enables you to build different versions of a model for different circumstances. So I've created a model here called Income Group. And what Income Group does is basically based on customer key and amount and age, it tries to predict whether somebody is in a high income, a low income, or a moderate income bracket. And I've created one model without a filter, but I've also created two models which have filters. So, for example, if I was to look at the Grays model here...
No, I'm afraid to see the age query here, but anyway.
Well, the age query is a very, very special one here, because when I look at the filter, it's greater than 46. If you actually saw this demo a month ago, it was greater than 45. But now the Grays are greater than 46. And, of course, equally useful and dynamic is less than or equal to 46.
Woo, I'm safe.
And I'm just safe. Now, the purpose of this is I now have three models, all of which are essentially the same, but they're filtering out the source data. Why is that important? Well, it means that I can see which of these models have the best characteristics for making predictions. So if I look, for example, at the mining accuracy chart, and I ask it to see how well these models predict, say, high income bracket, and I can ask to see all three models beside each other, and I'm going to use the test cases from the model that I created, so that's 30% that we held out. And now when I look at the lift chart, which is the chart that shows me the accuracy of the model, I'm going to see essentially three different views of the data, each showing the prediction values for the three models. Now, the blue line running up the center here, that is the random model. That is a model where basically if I wanted to know if somebody's in a high income bracket, I toss a coin and decide. So it's basically only a kind of 50% correct. If I look at, for instance, this light blue line and the purple line and this kind of pinkish line here, the straight lines, these are the ideal models for different, for the Grays, for the youthful, and for the unfiltered model. And here are the results from those models. And in fact, the further away these lines are from the random line, the better the model is at making these predictions. So I can see that the Grays model is much better than the random guess, but it's not as good as either the unfiltered model or the youthful and dynamic model. So the youthful and dynamic model is the best one for predicting whether somebody is in a high income bracket. And if that's an important calculation for me, that's the one I was most likely to use. And that's the value of filtering. You can actually, very often there are subsets of your data that you want to specifically build models for and see if they're better. My other favorite example is if you're in a clothing store or you're doing some sort of retail of clothing, you probably want to build a separate model for females and a separate model for males because their characteristics are so very different when it comes to shopping, especially shopping for clothes, that the model that works for one is very unlikely to work for the other. And that's a kind of fairly typical example of why you would use that. So with that, having covered some of the kind of improvements in the structure and some of the improvements in the testing of the model and the filtering of the model. Let's get back and talk about a few of the other kind of catch up on the questions there,
okay,
and go into some more features.
Okay, yeah. So as you can see the poll question here, each filtered data set in a mining model uses a different training and testing data. So what do we think it is? Do we know? And which algorithm does not support drill through? Okay, good. So indeed, those answers were correct. So we're going to move on into a new feature that we've added in 2008 that has to do with validation. It's great that Donald just showed the lift chart, because those of you who have been doing data mining for a while are probably familiar with both the lift and the profit chart, which are visualizations of the effectiveness of models. We have had requests from customers to incorporate a more sophisticated type of validation, and we've done that in a new section of the validators called the cross-validation. So I'm going to just go through this and talk about it here, and then Donald is going to show it. So the cross-validator is an alternative method of validation, which means that you would not have to hold out separate data, first of all, to create a testing data set. Basically what it does, as it says here, is it splits the mining model into partitions of equal size, and you can actually configure how the splits are built. And then it iteratively just validates through all these different partitions. So it gives you a more sophisticated type of validation. So one of the things I know I asked when I was learning about this is, why then wouldn't just everyone use this? And the answer really is it provides a level of sophistication that is needed by some customers but not by all customers. So you can think of it as an either or. So either you choose to do lift chart or possibly profit chart, or you choose to do cross-validation. Also, the results of the cross-validation are designed for people who are quite experienced with data mining concepts and even statistics. So to that end, I'm actually going to turn it back over to Donald to show us how the cross-validation works and to talk to us a little bit about the results.
Thanks very much. I think the cross-validation feature is one of those ones which we've been asked for by specialists in the data mining field. They've said, do you have cross-validation? It's a technique that we want to use. But I'm going to tell you that although we've implemented this in response to questions from specialists, we actually think there's a lot of value for this for the non-specialist user, and we've tried to make it very easy to use for the non-specialist user so they can get that advantage. So when I share my desktop again, rather than going back into the specialist tool, I'm actually going to go into the Excel environment and show you cross-validation in the Excel environment and give you an idea of why we think this is kind of exciting. Now, just to make it clear what I'm doing, I'm going to close this window because I'm not going to use the data that I've got here. I'm actually going to go back and look at that data from the kind of grays and the unfiltered and the youthful and dynamic model, and let's cross-validate that and see how that compares. So what I'm going to do here is choose cross-validation on the data mining tab and click through the wizard. And you'll notice that although I have a lot of models, I can either choose to cross-validate a model, but if I click on the structure name, I'll actually cross-validate all the models in the structure. And that's really valuable because I can build a lot of models using filters and using different parameters over a single structure, and then I can compare them all and see which is best using cross-validation. So here, because I've selected the income group structure, all these three models will be cross-validated. And in cross-validation, I get choice of the various parameters. The number of partitions or folds that I want to split the data into, I'm going to use 10. The target attribute that I want to test for, I want to test again for targeting the high income group. And I have some other options which are a bit more advanced, but this is basically all I need to do at this point. It does give you a warning, and the warning says here that because maximum rows is set to 0, cross-validation is going to use all the rows. So this could be expensive. This could take a long time if I have a ton of data here. But in fact, in this case, I know I've got a relatively small amount of data, so it's okay just to click Finish. And it tells me here that I'm creating a persistent object, which is going to destroy contemporary objects. And that's something you should be kind of aware of when you're using the Excel tools, that the Excel tools mostly create temporary objects in your database. That's why the IT department can easily provision you a database and be sure that when you're building the models with the data mining add-ins that you're not running away with a lot of resources. But this model for cross-validation is actually going to create a permanent object on the server, and we just give you a warning that as soon as you create a permanent object, any temporary objects in the same session will be deleted.
Donald, I have a question about that. So when you're creating, when you're running cross-validation using Excel, is it a requirement that it's created as a permanent object, or can it be created as a temporary object?
It is actually created as a permanent object.
Okay,
yeah.
Okay.
We don't even give you the choice.
That's what I thought you said, but I wanted to just clarify that. Okay.
Yeah, sure. So here's the report, the cross-validation report, and you can see here that there's quite a lot of information. If I scroll down here, you'll see quite a lot of various values that we've given. And I'm not going to go through every single one of these validation values, but I wanted to give you the highlights. First of all, we tell you that we created 10 folds of cross-validation, 10 partitions. We used 12,939 rows. And the models here, let's look at, for example, true positives. Now, remember what I was saying about, true positives are where you want to sell to someone and they actually are a good target customer. They absolutely do want to buy. Notice that youthful and dynamic model and the Graves model give values around 150, 180 for the mean and standard deviation of those values. What does that actually indicate? Well, if you're a technical user and you want to get into those details, this is all documented for you. But remember, I tried to say that this is also useful for the non-technical user. We actually highlight the best value in each case. So even if you're a non-technical user, you can tell at a glance that the unfiltered model is actually the best one for true positives. What if you want to avoid false positives? What if, for example, you're going to give somebody a free test drive or something, and that's a big cost to that? You want to avoid giving false positives, giving free test drives to unlikely customers. In this case, we highlight that youthful and dynamic model is the best for that scenario, and so on. We can go through true positives, false positives, true negatives, false negatives, and then down onto some very specific statistical measures, such as the log score, the lift value, the root mean square error. And at this point, some of you are thinking, oh yeah, I understand that. And others of you are thinking, well, I don't really even know what those are. But the great thing is we do give you the best values for these. And if you need to know more information about them, you can look them up in the documentation. So we've taken what we think is a very advanced data mining feature and tried to make it very easy for the user to understand.
Donald, I see a question in the queue that's talking about advanced capabilities in Excel, so I'm just going to go ahead and ask you live. It says, does Excel provide a capability to get confidence intervals in tabular or graphical form? Can R-square be reported on as well?
So we do have a classification matrix that can give some of that information, but in fact, we don't think of the data mining tools in Excel as providing advanced statistical capabilities. But Excel, of course, itself, especially if you had the analysis add-in for Excel, the analysis pack for Excel, which comes with Excel Professional Edition or Office Professional and is an optional install, that actually gives you all that information. So we haven't replicated any of that functionality because it's already actually available in Excel using the analysis pack.
Okay, great. Okay, so let's go back to the slides then. So keep going. So I'm going to leave this poll up a little bit longer. I got a little feedback that I was going a bit fast on the polls. So which two algorithms are not supported by cross-validation? Anybody got any guesses? Looks like we have some brave souls out there. And good that we're reviewing, because it's actually, if you think about it, it makes sense. It's actually time series and sequence clustering. And if you think about how cross-validation works, it should be logical, because cross-validation is breaking your source data into multiple partitions and then validating across the partitions. So if you have data that is being calculated against based on these series values, when you break it into separate partitions, then you might lose the meaningfulness of the series. So that would be why time series and sequence clustering are not supported by cross-validation.
Yeah, that's a good point.
So you can cross-validate only one model at a time, true or false. What do you guys think? That one you're doing great. Yeah, it is false. one of the purposes of cross-validation is to be able to validate multiple models. Now, you didn't do that in your sample, Donald. Do you want to maybe give a business scenario of where that might be used? Because I think that might be good information for the audience listening.
Well, actually, I did do that. That's where I compared the grays and the youthful and dynamic.
Oh, yeah, I'm sorry. Of course. Sorry, yeah. So comparing the filtered models, I guess I was thinking of models. I'll ask you a question. Would you get meaningful results if you used models that were based on different algorithms?
Yes, you absolutely would.
Yeah, I would think so. But that's the scenario I was thinking of. I just didn't say it correctly.
Yeah, sure. You want to find out if naive Bayes is better than logistic regression or something. Absolutely, that's a great use for it.
Yeah, because with the filtering being new, I would think that more people would probably use cross-validation with mining models that were built off of different algorithms rather than the same algorithm being filtered.
Yeah, for sure. That's
where I was coming from on that one. Okay.
Another point, by the way, is that all the models have to be in the same structure.
Yeah. Okay, so we left the largest amount of time in our presentation for the time series algorithm because we have made quite a lot of changes to the time series algorithm, and it is a very popular algorithm, which if you've used mining, you're probably familiar with it. What it does, if you're not familiar, is it allows for time-based forecasting. So how many of X will I be predicted to sell at some future point? I know in my experience using this stuff in production before I joined Microsoft, it was probably one of the most popular algorithms. Do you find that to be the case with enterprise customers, Donald?
Yeah, it's the first thing they think of.
Yeah.
Is to use to do predictions.
Yeah.
And you look at time series. Yeah, for sure.
Yeah. So what we've done is we've made some extensions to the time series algorithm based on customer requests. In Analysis Services 2005, we had a single algorithm. It's the ARTXP. So it stands for Auto-Regressive Tree Model for Multiple Prior Unknown States. And no, we won't put that on the quiz. But basically that algorithm was designed to accurately predict the next step in a series. And you can think of it as a short-term predictor. So if you had 10 steps or less, it would predict fairly accurately. But what we found in talking with customers is that customers were wanting to predict over longer periods of time. So we got a lot of requests to integrate a very well-known algorithm in the data mining industry. This is the ARIMA, which stands for Auto-Regressive Integrated Moving Average. And what it does is it improves the accuracy of predictions when there is a series of more than 10 steps. So what we've done is we've added 2 of these algorithms into the time series algorithm. And the way that they work is dependent on which edition of SQL Server 2008 you're working with. If you're working with the standard edition, then both of these algorithms are implemented when you use time series, and the results are automatically blended to produce the best ultimate result. If you've got the enterprise edition of SQL Server 2008, that's the default behavior, but you can also manually tune the execution of these algorithms in order to improve the results after you do testing. And as we continue on, and basically that just says what I said, and now I'm going to give Donald some time to show how these work.
Okay, thanks very much. I think one of the most interesting thing about the time series algorithm is that people really feel that doing predictions is an essential part of doing data mining. They think that it's very much about looking into the future, and we actually talk about predictive analytics. Data mining, we often describe it as predictive analytics. So that's actually kind of pretty important. One of the things, though, that we want to get across is that data mining, we've shown, covers many areas. It covers clustering and understanding customer behavior and so on. But prediction is almost like a specialized area within data mining. And so in some ways, the algorithms behave in somewhat different ways, and they're used for somewhat different uses. So let's first of all have a look at a straightforward time series model using some sample data, and then we're going to go out and we're going to try something a little bit different and see if we can make that work.
Okay, and before you get started, I see I have a question in queue here, so I'll just share this out. The question is, can you model seasonality in the forecast?
Oh, absolutely, yeah. And in fact, we'll show you how to do that.
Yeah, that's what I was thinking. So.
Great. So what do I have here? I have some sample data, and this is kind of made-up sample data. So it's from the sample data set that you get with the data mining add-ins when you download them. But it's kind of useful just to give you an idea of how these various algorithms work. It shows me data for a series of months of sales of the M200 mountain bike in Europe and North America and in the Pacific region. And this data is formatted as a table. Now, there's two different ways we can do forecasting. I'm going to show you the easy way, then I'm going to show you the more detailed way. The easy way is to go to the table analysis tools and ask to do a forecast. We just click forecast. It asks us the data that we want to forecast. You can see Europe, North America, Pacific. Yes, we want to forecast them out. We're going to forecast 5 units. We're going to use the year month as the timestamp. And the question about seasonality is here. Yes, we can ask for different periodicities or seasonalities, and we can give hints as to whether this data is changing weekly, monthly, quarterly, yearly. But if you know the seasonality, that's fine. You can predict that. You can put that in here, and we will use it. But we can also detect it automatically. And honestly, unless there's an unusual seasonality that you don't think the algorithm might pick up, I would normally expect to detect automatically. Let's run it first with detect automatically, and I'll show you that.
Now, just to be clear for everyone, too, even though the time series algorithm has been enhanced, this capability on the table analysis tools to forecast is already present in SQL Server 2005.
That's right. It's already present in 2005, and this just now takes advantage of the new default algorithms that we've added.
Which, in essence, improves the results over long-term predictions.
That's right, yeah. So in this case, as you can see, we've predicted forward. Here's the historical data, and we predicted forward the European amount, the North American amount, and the Pacific amount. If you focus on the American amount, this red line here, I think what's interesting about this in particular, and let's just see if I can format that line and make it a bit bolder for us. Let's look at the shape outline, see if we can make it a bit thicker there. Just to call this out. Now, there's the American data just called out there for you in more detail. And you can see there that we predict that this is going to fall, and it's going to rise again, and it's going to fall. And this is because we've detected the periodicity of these, of these spikes in the data. And we've used that when we're projecting forward. I'm only projecting forward 5 months. But you can see here that, given the basic defaults, run through the wizard and just say yes to the results, you can actually get a kind of pretty interesting prediction that already knows about periodicity and can do those charts forward. Let's delete this forecasting report and just do the same one again quickly. What I'm going to do here is ask for exactly the same data, but what I'm going to do here is use year and month as a timestamp. And now I'm going to project it a bit further forward and ask it to project, say, 20 months in advance. And actually, let's just look at the North American amount just to make it clear what we're doing. So now I'm going to run this analysis. And remember, I have a limited amount of data in the model here, but you can see that, again, we've picked up the same periodicity. And even though we're projecting it further out, you can see that the trend that we're predicting is more or less the same as has been continuous. And the spikes, the peaks and troughs that we get here follow the periodicity of the previous peaks and troughs. So even projecting 20 steps out, we can actually get a pretty reasonable prediction on this data, pretty reasonable projection of it. Just for those of you who are concerned about periodicity, I can do one more thing, even in the simple environment. Remember, this is the simplest tool we can use. I can go in here and ask for a forecast, and again, I'll take North American amount, and let's do it 20 steps forward. Use this as a timestamp, but now I'm actually going to suggest a periodicity. And I haven't really looked at the data properly. I've been a bit silly, and I'm going to say I think it's got a weekly periodicity. In fact, this is monthly data, and I think there's a weekly repeating pattern. I'm going to run the analysis, and I'm now forcing it to accept the periodicity, and it all goes wrong, because at this point I've told it to take a periodicity which is in fact completely inappropriate for the data. So in this case, I'd have been a lot better off just going with the default in that case. Okay, so what I'm going to do is just delete this forecasting report. I'm going to go back to this table and just delete some rows, all the predicted rows from the end of it. And if I can just remove them, get back to some raw data, and we're going to move on and do slightly more sophisticated prediction using the data mining tools.
Now, as you're moving from the different ribbons in Excel, a question that customers will ask me very frequently, and I think a lot of our listeners would appreciate hearing your answer to, is why the team chose to put some of the new functionality that we showed earlier in the table analysis tools ribbon rather than data mining ribbon. And just sort of generally philosophically, what's sort of the conceptual target difference between the table analysis ribbon and the data mining ribbon in terms of who you guys think is going to use which tool?
Yeah, that's a great question. The way we factor this, it's actually fairly straightforward. First of all, you can install them separately. You can choose to install the table analysis tools and not install the data mining option. And the reason they're separated out is, again, the table analysis tools are intended for somebody who really has no idea about data mining at all. The functions that we describe are very task-oriented. It's about do predictions, do shopping basket analysis, do fill from example. There's no talk here about algorithms. There's no talk here about parameters. It's just, I want to analyze my data. Go help me do that. And it's for people who don't want to know, and it's for people who don't know that much about it. They're actually quite powerful tools, and as you can see, you can play with them a little bit, and you can change some things there. There are some more advanced options within that, but essentially they're intended for people who just want a one-click analysis. The data mining tab, on the other hand, is really intended for people who understand a little bit. At the very least, they understand the data mining process. They may not think of themselves as being data miners in any way, but they understand that a lot of data mining is to do with data preparation. And they understand perhaps about clustering and classifications. They don't know the difference between linear and regression and logistic regression, but they do know, I want to do classification, I want to do forecasting, I want to do association. So if you are an advanced user, a very advanced user who does understand these things, you could actually go in here and using the advanced model, I could go into a structure and use any of the algorithms which are available and walk through that and build a complex model and use all the algorithm parameters that are available. But most of the users here they're choosing tasks rather than algorithms. If you go back to you think of the wizard in the original wizard here in this environment, if I build a model using this wizard, the very first question it asks me when I want to create a new data mining model, if I go in here, is what algorithm do you want to use? What data mining technique do you want to use? If you don't know the difference between linear and logistic regression, how do you know? How do you choose which technique? So the data mining tab here in the Excel environment is designed to talk about scenarios rather than detailed techniques.
So you can actually see that people who are maybe database administrators might start by using the data mining tab inside of Excel to actually teach themselves what capabilities are part of data mining in
Absolutely.
analysis services. So this is actually kind of a junior admin tool in a way.
It is actually, yeah. I mean, it's very flexible from that point of view, and it walks you through the process. If you walk from left to right along this ribbon from preparation and modeling, and then validate what you've done, and then use the model and query it, you can see that it's actually quite a natural flow here.
Mm-hmm. It's just not a typical place for us to look for an admin tool for a database professional inside of Excel.
Sure, yeah, but I think of it more of an analytic tool than an admin tool.
Yeah,
for sure, yeah.
Yeah, because it relates to a question that we have in the queue. He's really just getting started with all of our BI capabilities, and he says, where do we think would be a good place for people listening who are just intrigued and wanting to get started with data mining would be? So where should they start?
I think the great place to start is the table analysis tool.
Yeah, I think so too.
It just gives you a sense of, one of the great things about table analysis tools is it's so easy to use that you can try many different things and see what makes sense to you. And, can you get a good, where can you get some good data? Maybe you've got some data yourself. Maybe you can go on the web. There's great sites like Swivel where people can share data. And in fact, I'm going to go on and just get some data in a moment to do some analysis. In fact, I can do that just now, actually. I was going to go on to, if you see the bottom of my screen here, there's I've got probably really depressing data is U.S. historical gasoline prices. But it's a kind of nice place you can go, and I can get historical prices of regular gasoline.
Well, as you're getting that too, doesn't your team maintain a site? Isn't it www.sqlserverdataMining.com?
That's right, SQLServerDataMining.com.
Yeah, with a lot of great samples and information.
So what have I got here? Well, here I have some data mining data for some data just straight from the government of gasoline prices in the USA from 1990. Look at that one, 19.1. That is depressing. Okay, so I'm just going to go down here, and basically I'm going to create a table of all these prices. And remember, this data isn't formatted as a table, so I have to, if I'm going to use data mining add-ins to do this, or I'm going to use the table analysis tools, I would want to format this as a table. So I'm actually going to say format as a table, and click OK, and yes, it has a header. And now I actually have a table of all this data. And this time series data, this is actually weekly data. All the way back from 2008 right back to 1990. So what I could do here is, if I want to do a time series analysis of this, let's just take a prediction and say let's do a forecast of, I'll just use the overall US data, just one column of it. As you can see, there's about 20 different series here that's available, so I don't want to use all those. So I'm just going to take US regular gasoline. I want to project it out for the next 2 months, let's say for the next 8 weeks. The timestamp column is the date. The periodicity, I'm going to leave it to detect periodicity and tell it to run. And I was going to run into this data. And I'm going to see if I get something interesting from that or not. In fact, I know what's happened here. This is my 8-week prediction is actually so small compared to the many, many hundreds of historical data points that I haven't quite
can't even see it, yeah.
Can't even see the 8-week projection in there.
Maybe you don't want to.
Yeah, I can tell you, it's going up.
Maybe it's a safety feature.
Yeah, exactly. Yeah. I guess I don't need data mining to actually tell me too much about this one. But for one point that I would want to make about this is, what affects gasoline prices? If I was actually looking at this data mining model, the only input to that time series model is the prices. And so it's only modeling, it's projecting based on historical prices. There's no additional information in there about hurricanes in the Gulf or the situation in the Middle East or Chinese demand or any of those other things that actually affect gasoline prices. So in the case of that projection, if I wanted to factor those items in, I would actually need to include other time series which track those things and said, what's the state of production, what's the overall world demand? Then I would be able to do a prediction that took all those factors into account. But if all I have is the gasoline prices, that's the only thing I can base a prediction on. People often often ask me things like, hey, so can I use this to predict the stock market? Well, I'm still working for Microsoft. I'm not making a fortune out of this. And the reason is there's all these other factors that are so difficult to factor in. And you have to try and understand those factors. When you're in control of the factors in your own business, and when you know all the factors, then of course this is a very, very powerful algorithm. But don't think it's a panacea. You don't just kind of click the analyze button and you're Warren Buffett. It's not as easy as that.
Yeah, but you were probably going to show us the time series and the ability to adjust in the data mining ribbon.
Yeah, sure.
In the Enterprise Edition to show us the difference between the table analysis version and the data mining ribbon version.
Yeah, sure.
A little bit more sophisticated, yeah.
What we've shown so far is the kind of the simple, literally one forecast.
Yeah.
To get into the full kind of functionality of the time series prediction, I'm going to use still forecasting, but it's now forecasting in the data mining tab. And this will really call out the difference between the analysis tools and the data mining tab. Because here at this point, if I want to project this data forward, you notice that I've still got the same data here. I choose forecasting, and you'll notice the difference in the wizard. First of all, it tells me a bit about what I'm doing. It gives me an option to choose data from a table or from a data range. In other words, it doesn't need to be formatted as a table for the data mining tab. It must be formatted as a table for analysis tools. It can even be an external data source, which is, in this case, I can use any analysis services data source. So the data could come from SQL Server, it could come from Teradata, it could come from Oracle, any of those sources. One thing, if you're thinking about those scenarios, that people always ask is, well, hey, if I'm pulling data from a data warehouse which has got terabytes of data in it, am I really pulling all that into Excel? And the answer is no. The data goes to the analysis server where it's analyzed and the results come back into Excel. So this is highly scalable. You can use this data mining add-in over millions of rows of data, way beyond the Excel data limit, because what you're using is you're using Excel as a client.
Yeah, I think that's really a key point. I'm glad that you brought that up because, again, when I demonstrate that out to customers, it's very difficult, I think, for them to understand that this is a client where the processing is running on analysis services, and the source data can be someplace else. So it's a three-tiered architecture.
Absolutely, yeah. So what I'm going to do here is I am going to project this data forward, and I'm going to use year month as my timestamp. I'll project the North American data, and now I'm going to choose the parameters. Now notice that here I've got complete control over the parameters, and you'll see here that the forecast method, the default, is actually the mixed algorithm of ARIMA and ArtXP. What I'm going to do here is I'm just going to use the ArtXP algorithm. So I'm going to say, actually I only want to use ArtXP. That's what we had in 2005. So I'm only going to use the ArtXP algorithm. And there's lots of other options that you've got here. But in this case, I'm going to use just change this one parameter. And choose next. And here, actually, we're predicting just North American amount. And I'm just going to, let's just give this a structure of a demo and give this model the name ArtXP. And I'm just going to finish this prediction. And again, we'll build the model in the server. Oh, sorry, obviously I already used the name demo in the server. So we're going to build the model on the server, train it, return the results into Excel as a separate viewer. And in this case, I can see the data that we have historically, and I can see the prediction going forward, the 5 steps in time that I've asked to see for the North American data.
Now, if you were, you have the Enterprise Edition and you're tuning this, you could use the cross-validation to validate the different models. That would be one of the methods.
Not for time series.
Oh, that's right. For time series, it doesn't work. That's right, because it's time dependent.
Absolutely.
So you'd have to use the standard validators. Okay.
And in fact, you'd probably just graphically compare the model.
Yeah, just look at it. Yeah. Okay.
So this was the 5 steps forward, and you can see that we've picked out the periodicity, and we've made a prediction which certainly visually looks to me has been quite useful. Let's remember what I said, that ArtXP is not so good in the long term. So let's move the prediction steps up to be about 25 steps forward. 6. But again, you can see the periodicity is kind of followed all the way up there, but it's kind of fairly automatic there.
Yeah.
There's not much kind of subtlety to that one. Let's go back and do another model this time using forecast. And in this case, I'm going to use the same data, and I'm going to remember to do something which is fairly important, which is remove any predicted data from the bottom, which I've done. So in this case, we're going to forecast, and I'm going to use the same data, predict North American amount. At this point, we're going to use the ARIMA and say OK. And I'll use, let's call this, demo 2. What's the name? ARIMA. At this point, again, we send the model to the server, train it, bring the data back. And let's see the prediction from here. And you can see the prediction from here is actually, in the short term, is not nearly as convincing as the ArtXP model. The other way is kind of dropped off there completely.
Yeah.
It's kind of really overcompensated on the periodicity there. That's where ArtXP is really good at doing those short-term predictions. However, if I now do this and project it out, say, 25 steps, and wait for it.
Yeah, you can really see the difference.
This is now quite distinct from that, and actually it's better in the long term than ArtXP, but in the short term, it's not nearly so good. And this is, again, you would try those models, but there is a rule of thumb, and the rule of thumb is actually given as the default, which is up to 5 steps, use ArtXP.
Okay.
Beyond 5 steps, use the mixed algorithm, and really when you get beyond like 10, 15, or if you're doing kind of just smoothing projections of 20, 30 steps out into the future, then that's a point at which probably use pure ARIMA. But the default option actually has all that built into it. And in most cases, choosing default is going to give you the best results.
Great. That's great information. And again, just to recap, on the standard edition of SQL Server, you get the default blending. In the enterprise edition, you can go and do custom blending.
You can do a lot of that kind of tuning of the blending there.
Yeah.
And that's really quite an advanced feature.
Yeah.
And honestly, nearly all the time I just use the defaults.
Right. Well, like you were talking about, I mean, if it were perfect and we could all quit our jobs and, play the stock market, then it would be, but that's not the case.
Exactly, yeah. Well, it's so often the problem is understanding the scenarios and understanding all the factors that actually come into this. And that's really, that's a lot of the work that goes into data mining, understanding the factors that may influence your model.
Right. Well, let's see how you do on this poll. Which time series algorithm makes a better projection at 15 steps? Well, there we go, ARIMA. That's what we talked about. Okay, and another poll for you. We talked about this. Standard edition does not allow you to pick, and it really should be blend. And that would be,
Yes, it's the blend that you can control within
it's not pick, it's blend. So, okay, great. Looks like we have some pretty good understanding of that. All right, so we showed you lots of new stuff, and we realized that we had different folks in our audience. We had experienced data miners, and we had people that are new to data mining. We did focus on the new features because that was the focus of this particular presentation. We did try to answer questions that were asked. If you have additional questions, now would be a great time to put them into the question queue, really about anything around data mining. It doesn't have to be the new features at all. So we talked about the new features that we incorporated inside of the Excel table analysis ribbon and data mining ribbon around the prediction calculator and around the shopping basket analysis and around the model documentation. We then went and showed new features that were related to model creation, and those included filtering so that smaller models could be created, drill through, which allows drill through back to the source columns in the data mining structure, again, so that smaller models can be created, and column aliasing. We talked about that. Donald then demonstrated, and I talked about the new method of validation that works with all but the time or the series-based algorithms, the cross-validation, and Donald demonstrated that using filtered models. So you could implement that either with filtered models with the same algorithm, or you could use models that were built with different algorithms. And it's a sophisticated type of validation that's an alternative to the more standard lift and profit models that are already built in. And then we finished by going through the time series algorithm enhancements, and Donald demonstrated the different results that you'll get by using the single algorithms, and then the results that you'd get by using the blended algorithm, and talked about the defaults and how you would further configure those algorithms if you had the enterprise edition of SQL 2008. So we tried to focus on all of the new features, and hopefully we gave you a good amount of value. Donald, do you want to add anything that maybe I've missed in talking about this?
Well, I think you've been very comprehensive in covering it, and looking back at it, we actually covered a ton of stuff. I think the main thing I'd want to add to this is just that, we've given you a flavor both of how easy it is to use this and how far you can take the product. There's a lot in this at every level. And it would just be great to hear from people who've tried this out at any level. We want feedback from people who are trying the table analysis tools for the first time, and we want feedback from people who hit the data mining models every day and are building advanced functionality. And the broader the spectrum of feedback we get, the better a sense we get of where we can take this in the future. But we're very excited about it.
Great, fantastic. Well, I think at this point we're going to turn it back over to the webcast producer, and if you have any questions, please put them in the queue and we'll get them answered. Otherwise, we'll turn it back over to the producer.
Great, thanks. If you have any questions for our presenters, please go ahead and submit those now. If there's any additional questions than what's already been answered. And we'll be getting to those in just a minute. I did want to remind everyone that you can print a PDF of the slides by right-clicking on your slide area and selecting Print to PDF, or by clicking on the printer icon in the lower right-hand corner of your screen. Also, watch your inbox tomorrow for an email with information about viewing this webcast on demand. The email will also include a link to a downloadable PowerPoint of today's webcast. One moment while I bring up the survey. You should all be seeing a survey in your slide area now, and if you can please take a moment to fill it out before you log off. We do appreciate any feedback you leave for us. All you need to do is follow the links provided to complete the evaluation. And with that, I'm going to go ahead and hand the floor back over to our presenters to make any closing comments.
I just want to thank everybody for listening in, and I want to let you know that I have a lot of information about implementation of business intelligence on my work blog, which is blog.msdn.com/SoCalDevGal, and I'm based in Southern California, and I am making quite a few live presentations about Microsoft's Business Intelligence Suite. So you can contact me through my blog if you're interested in having me come and speak to your group.
Yeah, I certainly recommend Lynn's presentation. They're really excellent. And for me, and again, I want to thank you all. It's been great speaking with you. You can contact me at donald.farmer@microsoft.com for any issues. And remember to look at our community site, www.sqlserverdataMining.com. Thank you very much.
Great. I'd like to remind everyone to take a moment to fill out that survey prior to exiting the session room. And with that, I'd like to extend a special thanks to Donald Farmer and Lynn Langett for today's presentation. Thank you all for joining us, and you may now disconnect from the audio portion of today's conference.